Question number 1. Integrate the functions given and following data points using Simpson's rule. The given number of elements in question is 10, but Simpson's rule requires an odd number of points. So first we will use trapezoidal rule for first 2 points and then Simpson's rule for the rest. The formula of Simpson's rule is h by 3 y0 plus yn plus 4 into odd terms plus 2 into even terms. According to trapezoidal rule, the formula is h by 2 into y0 plus yn plus 2 into y1 plus y2 dash 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 plus yn minus 1. Using this formula, we'll get the value of h is equal to 0.1, and after applying this formula, we'll get the value of f of x dx is equal to 3.1. Question number 2. Find the integral of f of x is equal to 2x cubed minus 3x squared plus 4x minus 5 from minus 2 to 4 using 3 points. We know that integral of f of x from a to b dx is equal to b minus a upon 2 f of a plus b minus a into y upon 2. Applying the above formula, we will get the function in form 3 integral to minus 1 to 1 54y cube plus 27y square plus 12y minus 2. Now using the polynomial formula, p of x is equal to 1 by 2 3x square minus 1, and from this equation we will find the value of x, that is plus 1 upon root 3 and minus 1 upon root 3. Using these points to solve the equation, we get question number 3. List the errors in computation of Simpson and trapezoidal rule. The error in using trapezoidal rule may be derived as expanding f of x in interval 0, h. In Taylor's series, we get f of x is equal to f of 0 plus x upon factorial 1 f dash 0 plus x square upon factorial 2 f double dash 0 plus x cube upon factorial 3 f triple dash 0. Now integrating, we'll get h f dash 0 plus h square upon factorial 2 f dash 0 plus x square factorial 3 upon f double dash 0 and so on. By trapezoidal rule, the integral is h by 2 f of 0 plus f of h, and expanding f of h in Taylor's series will get h by 2 f of 0 plus f of h is equals to h by 2 f of 0 plus f of 0 plus h f dash 0 plus h square upon factorial 2 f double dash 0 and so on. The final value will be h f of 0 plus h square upon 2 f dash 0 plus h cube upon 4 f double dash 0. The difference between equation 1 and equation 2 will be e is equal to minus h cube upon 12 f double dash 0 minus h to the power 4 24 upon 24 into f triple dash 0. Thus, this is the error in computation of trapezoidal rule. Similarly, the error in Simpson's rule can be calculated. It is given by minus h to the power 5 upon 90 f triple dash 0. Simpson's rule with n points gives about as much as accuracy as trapezoidal rule with 2n points. If Gauss quadrature is used, B may attain the same accuracy with n upon 2 points. Thus, the computation efforts required by Gauss quadrature is half as much as that needed by Simpson's rule. Solve the equation dy upon dx is equal to minus xy, where y0 is equal to 1 using predictor corrector formula. The predictor corrector formula is y of predictor is equal to y1 plus 2h s2 and y of corrector is equal to y2 plus h upon 2 s2 plus s3, given x1 is equals to 0 and y1 is equals to 1. So we will get the value of x2 is equal to 0.05 and y2 is equal to 0.999 using use method. The value of x2 will be minus x2 y1 is equal to minus 0.04995. Substituting the value of x as x and y1 and y3 will get the value 0.99505. Now putting the value of x3 is equal to 0.1, s3 is equals to minus 0.0995. Substituting the value of sp3, y2 and s2 will get the value of y3 is equal to 0.9953. Economize sin x series to obtain 3 significant digit accuracy. According to the question, the result is required to 3 significant series digits and the truncation error after 3 terms of series of equation is 1 upon factorial 7 and the truncation after 3 terms the sin x is equals to x upon x cube upon factorial 3 plus x to the power 5 upon factorial 5. Therefore, the value of x3 is equal to 1 by 4 3 into t1 plus 3 t3 and x5 is equals to 1 upon 16 10 t1 plus 5 t3 plus 5 plus t5. Substituting the above values in the series, we get sin x is equal to t1 minus t1 upon 8 plus t1 upon 192 minus t3 upon 24 plus t3 upon 384 plus t5 upon 1920. That is 0.8802 t1 minus 0.0391 t3 plus 0.00053 t5. The coefficient of t5 is 0.0052 for all x in truncation error, and if we omit the last term above, we still give 3 significant digits accuracy. Thus we get sin x is equal to 0.8802 t1 minus 0.03906 t3. Substituting t1 is equals to x and t3 is equals to 4x cube minus 3x, we get sin x is equals to 0.9974x minus 0.1562 x to the power 3, which gives sin x to 3 significant digits.